Go over again the y equals 2 over 8.
Yeah,
That part, the bottom part, just go over it again because I didn't get that part.
okay. So let
Because it
me,
got it since with can you erase the bottom part too? Because it's getting
this part, right? This is,
yeah. Yeah.
okay,
I know that the first point is 2.
okay. So we know that we worked out that when we did this x equals negative b over 2a to get the vertex, we got positive 8 over 4, which worked out to be 2. Okay, I'm going to erase this now so I have room to work. I think it's just got too squashy. So when we're using that formula, x equals negative b over 2a, that is only giving me part of the vertex. It's giving me, the vertex needs an x and a y. It's only giving me the x. So in this case, we got that the x is equal to 2. We're, um, so now, in order to figure out what the y is, we're going to take our original equation that we were given, this equation over here, and wherever I see an x, I'm going to put a 2. So it's going to be 2 times, here's my x, 2 squared minus 8 times 2 plus 5. And then I just work it out. 2 squared is 4. So this part is 4, and so it's 2 times 4, so that gives me 8. Then it's negative 8 times 2, so that's minus 16, and plus 5. And let's add the, and again, you can use your calculator. If you want to make sure you don't make any mistakes, you can use your calculator or check it on your calculator. 8 minus 16 is negative 8. Negative 8 plus 5 gives us negative 3. So my y value is negative 3, and my x value is 2. So the vertex is the point 2, comma, negative 3. Notice I put it in parentheses because it's a point, so the point usually has to go in parentheses. Is that clearer, Jennifer? Was that clearer?
Yeah.
Okay, great. Okay, so can I now erase this?
No, no, you can't. Sorry. Can I just write it before you do?
Okay,
All right.
I'm gonna leave. I'm gonna give you a minute because I really want to. I find that that's a problem with putting these problems on the board. It sort of makes everything rather messy. So I'll give you a minute to
Thank you. Thank you.
copy, and then we'll do. I'll erase it and I'll do this problem. Okay, just give me a heads up when I can go ahead.
Okay.
Okay. All right. So now we're going to the second question.
No, I didn't mean to rub it out first. Sorry. I was saying I'll let you know.
Oh, okay. I'm sorry.
Okay, you could go ahead. Thank you.
Okay, thank you. All right, so let's look at the second question then. The second question is about a right triangle. We started talking about right triangles on Tuesday. That's what we're going to continue with today. Again, the last half hour of the class from now on is going to be devoted to review for the final. I'm not doing one day a whole review. I'm doing it in sections. Today we're going to be reviewing chapter 1, but let's continue what we're studying right now. And that's, what do we do when I give you a right triangle, and I ask you to find the third side, the missing side of a right triangle. So if you remember, there's a special formula called the Pythagorean theorem that a squared plus b squared equals c squared, where a and b are what we call the legs of the right triangle, and c, the one that's always on the other side, is the hypotenuse. Remember, if you wanted to put letters on here, we usually put the C by the right angle. So the one that's right across it is what we call the hypotenuse. The A and the B we could interchange. I usually put the A on the bottom and the B on the top, but there would be nothing wrong with putting the B here and the A here. Now, if you recall what we said that these are the angles, the capital letters. The lowercase letters are what represent the sides. And they're across from each other. So this would be side C, this would be side A, and this would be side B. Again, we use capitals for the corners, for the vertices, for the angles. We use lowercase letters for the sides. Again, in a specific way. Once I have the capital A over here, the only place I could put the lowercase a is right across from it would be over here. Now, if I stick in these numbers in the a squared plus b squared equals c squared, I'll get 4 squared plus 6 squared equals c squared. Now remember, c is the one that I don't know. So 4 squared is 4 times 4, which is 16. And 6 squared is 36, equals c squared. So I have to add the 16 and the 36. So that gives me 12, that gives me 52. So c squared equals 52, which means that the c is the square root of 52. This is my answer. Don't forget, your last step is to get the square root. Notice usually when we have, let's say, x squared equals a number, when we take the square root, we get 2 answers, plus or minus. But in context, the minus wouldn't make sense because the side, how long something is, can't be negative. So that's why we only use the positive answer. How do we give this answer? So there are 2 ways. One way is, if possible, is to simplify the square root. Now remember how you simplify square roots. You break it up into 2 numbers, one being a perfect square and whatever is left. And if you notice, 52 is divisible by 4. We could break this up into 4 and 13. And the square root of 4 is 2. So my answer in simplest radical form would be 2 radical 13. Now, occasionally, they ask it for decimal form. If they ask it for you in decimal form, let's say they say to the nearest hundredth. They could ask it nearest hundredth, nearest thousandth. Let's say in this case, they asked for the nearest hundredth. How do we go about doing that? Now remember, how many decimal places is the nearest hundredth? Well, the tens place is 1 decimal place. The hundredth is 2 decimal places. What I do is I can only do this using my calculator. I go to my calculator and I do 2, then I put in my square root button, and every calculator has it in a slightly different place, and I put in the 13, and when I press equal, I get something that looks like this, 7.2 211102551. That's what I see. This is an irrational number. It's a non-ending, non-repeating decimal. If we want it to the nearest hundredth, we want to go to two decimal places. So we want to stop over here. When we want to round off, we always look at the next number. If that number is 5 or more, we have to increase this number. But it's 1, so my final answer to the nearest hundredth would be 7.21. So sometimes they ask you not in radical form, but in decimal form. If somebody was using this in a practical situation, then they'd really want the answer as a decimal, because if you really wanted to measure it, you couldn't. How do you measure 2 radical 13? You can measure 7.21. Is there any question about this? Any questions? Okay, so then can I erase this? Anybody need it longer? Okay, so I'm going to erase this, and I'm going to continue from here. We're going to continue our discussion of right triangles. And what we're going to be going on to is in the trigonometry of right triangle. And basically, what we have to do in terms of trigonometry is just learn the definitions. There are 6 terms that we have to learn how to use, to know what they are and how to figure them out. There are what we call 3 primary trigonometric functions, and there are 3 secondary trigonometric functions. Let's start with the primary ones, the more important ones. There's something called the sine, which is abbreviated. I'm just going to use the abbreviation SIN. There's something called the cosine, which is abbreviated COS. And there's something called the tangent, which is abbreviated TAN. If you look on your calculator, anybody, if you have a scientific calculator, you'll see a button that says, looks like it says sin, but it's sine. You have a button that says cosine. You have a button that says tangent. These are the primary ones. They're important for trigonometry. Again, we're just doing an introduction to trigonometry. So we're just going to tell you what these are and how to figure them out. All the things, and there's so many things, once you know how to do these things, there's so many things that build on these concepts. But of course, that's part of pre-calculus. That's not part of this course. Our is to figure out, what do these things mean and how do we figure them out? So let's show a picture of a right triangle. Let's call our right triangle ABC. And remember, I use this little square box to indicate that the right angle is over here. And just as we've done before, this is our small a, it's across from capital A. This is our small b, and this is our small c. And these, of course, we saw how really we don't need to know all 3 of these numbers, because once we have 2 of them, we could always figure out the 3rd number. First of all, this is really a topic that came through the Greeks, as I mentioned. So very often, instead of using regular English letters, Sometimes instead in trigonometry we use Greek letters. Now I'm just going to indicate really one Greek letter that often comes up. That Greek letter looks like a zero, except it has a line across it. This letter is called the Greek letter theta. There are other Greek letters. Alpha is a Greek letter, beta is a Greek letter, but just like X is the most common letter used in algebra in English language, the most common letter used for a variable in Greek is this letter theta. In other words, instead of calling this angle A, you may see this symbol here, this symbol of theta. I can call this angle A, or I can call it angle theta. Sometimes it's done with the regular English letters. Sometimes it's done with the Greek letters. There's nothing very special about it, except that it's used exclusively for us. And in mathematics, when we use it, it specifically is in the topic of trigonometry. And it's used really for names for angles. So when I see an A, I'm not sure if it's an angle or a side, but if I see a theta, I know it's really referring to an angle. Okay, so that's just introduction. If I look, let's look at this angle A or this angle theta and label the sides relative to the angle. Well, side A is directly across from angle A. So this is called the opposite leg. This side is right across from the right angle. The side that's right across from the right angle is called the hypotenuse. And the third side, the one that's right next to angle A, sort of attached to angle A, that is called the adjacent side. The word adjacent means next to, so this is called the adjacent. So the A and the B are the legs, one being opposite the angle and one being next to it, the adjacent. And then the third side is the hypotenuse. That's always the one that's across from the right angle. Now, if you notice, I have to tell you what angle am I looking at before I can tell you which is opposite and adjacent. Because if I was looking for from the perspective of angle B, well, C would still be the hypotenuse because that's right across from the right angle. But in terms of B, this side would be the opposite and this side would be the adjacent. So whenever I talk about finding something like the sine of an angle, I can't just say find sine. I have to say sine of what? Because I have to know which side angle am I looking at, from which perspective. So for us, let's first look from the perspective of the angle A. So again, I won't ever just say find sine. I will either say find sine A, or I may say find sine theta, or I may say find sine B, but it has to be sine with a letter next to it, a name of an angle next to it. Okay. Now, what does the sine stand for? The sine stands for the opposite side over the hypotenuse. In other words, each of these names are really a fraction. They're a fraction that you get by dividing one side of the triangle by another. Sometimes they're called ratios. These are the trigonometric ratios because each one represents a specific fraction. The cosine, remember we said the sine is the opposite over the hypotenuse. In terms of these letters, the sine of A would be small a over C. The cosine is the adjacent leg over the hypotenuse. In terms of these the way I set it up, the cosine of A would be the adjacent, which is B, over the hypotenuse, which is C. Remember, these are lowercase letters because these are sides. This is a capital letter. The cosine of angle A is the ratio, the fraction we get by taking the adjacent side and dividing it by the hypotenuse. And the tangent is the opposite leg over the adjacent leg. In terms of this, if I'm looking for tangent A, I do the opposite, which is the A, over the adjacent, which is the B. Now, there's nothing very complicated about this. It's just a matter of finding these numbers. So let's do an example with actual numbers, and I'll show you how to work it. Okay? Can I erase
I'm still copying. No, wait, I'm still copying.
Okay. You know what, while you're copying, I'm going to take attendance. At least I was gonna take it. Oh, here's my attendance. I'm losing it today. Okay, I don't have a pen. Where's my pen? Okay. Azia, I know you're here. Nashia,
Yes,
good morning. Nashia Allen. Is she here? Annabelcus, Emma, I know you're here. You were not here on Tuesday, were you? Emma? Oh, her thing is not working. Okay. Mic is not working. Messiah here? Corey, I see you're here. April, I know you're here. Khadija, you're here.
Yes.
Khadija, I have you absent a lot. Is that true, or were you here and I just got it wrong?
No, I have been here. I just haven't been, I think last week I had missed a day.
Okay. But you were here on Tuesday?
Yeah.
Okay, I'm sorry. Okay, I'm changing that. Okay.
Because I couldn't get in at first and I had sent you the email.
Yeah, sometimes I just, I forget to change it on my attendance sheet. It's not a problem. I know who is often absent and who's usually here. Okay, Umar, you're here. Yakima Ellison. Yakima. Cheryl, I know you're here. Stacia. Stacy, you here today?
Yeah, I'm here. I'm here, Professor.
Okay, you usually are. Danisha. Devon, I know you're here. Natalie.
Good morning, Professor. Thank you.
Yeah. And Natalie, I'm pretty sure you were here. Natalie, were you the one who sent me an email that said you had tried to get on and you had trouble? Somebody sent me that.
No, that wasn't me.
It wasn't you. Were you here on Tuesday?
No.
Oh, okay.
I attended, but then I wasn't there for the rest of the class.
Okay. I got you. I'm gonna change you to here. Okay. Erica. Erica here today? Jonathan.
Here, I'm here.
Hi, good morning. Luke, pretty sure I saw your you're here, okay. Layla,
Yes, I'm here, Professor.
good morning. Ashley, I'm pretty sure you're here also. Ashley here. Let's try it. Yeah, I see Ashley is here. Kachira, you're here, I know.
Here.
Good morning. Jennifer, of course, I know you're here. Rachel Seeley. Rachel's not here. Okay. All right, so now let's see, now that I gave you these interpretations, let's see an actual working out problem and how we do that. Okay, in order to do that, I'm going to erase this and draw a new picture because it's just, again, it's getting messy. Now I erased it. How am I going to remember what sine stands for, what cosine stands for, what? I know I'm going to remember it, but how are you going to remember it? Because that's the big thing. How am I going to know what anything stands for? So I'm going to give you what's called a mnemonic device, an easy a way of remembering what the sine, what the cosine, and what the tangent stands for. Because you're not going to get this on the test. You're going to be asked to find the sine of something, and you're not going to know how to do it because you're going to forget what does the sine stand for. So here's my mnemonic device. You have to have a picture in your mind. That's what a mnemonic device is. It's a picture that reminds you of the name of something. Like, for example, if somebody's name is Chapeau, Mr. Chapeau. Now, chapeau is French for hat. So if you just remember a picture of a hat, you may remember his name is Mr. Chapeau, even though you may think, oh, his name is Mr. Hat. But at least it would be a way of reminding you what the thing is. So how does this mnemonic device that I'm going to tell you work? Okay, so you need a picture. It's freezing cold out. And you come in from the freezing cold and your feet are frozen. So what do? I mean, it's not a smart idea, but what do? You take a bucket of hot water and you stick your feet into the hot water. In other words, you soak your toes. That's the reminder. So, ka, toa. You soak your toes. Soak a toe. Soak a toa. How does this help me in any way? Because the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So those three fractions that I told you had to remember are all reminded to you over here. You know what I do when I start a trigonometry test? The first thing I do is I write down SOHCAHTOA, because that's the most important thing. If I know that, it's half the game. Here's an example. I'm going to take one off of a okay. They give me a picture that looks like this. A, B, C, this little square here. So here's my right triangle. I'm told that this side is 3 and this side is 5. And they put this theta symbol over there. In other words, this is the angle that we're looking at. And they asked me to find cosine theta. Okay. So in order to find this, the first thing I have to do is label my sides: opposite, adjacent, and hypotenuse. Here's my angle. The side that's opposite that angle is this. Here's my opposite. Let's just put a big O. Which is my hypotenuse? Well, that's the one that's always across from the right angle. So therefore, this is my hypotenuse. And the third side, the one that's, notice I always put the hypotenuse first before I go to the adjacent, because actually every angle has two sides. One of the sides will always be the hypotenuse. The other side that is attached to it, that's the adjacent. I'm going to call it AD because I don't want you to mix it up with this A. So here's my, if I look at angle theta, I can label my sides relative to angle theta: opposite, adjacent, hypotenuse. Now, they asked me to figure out what the cosine of theta is. So I know that the cosine, so ka means adjacent over hypotenuse. That's what the cosine is. Let's see if I have all that information. Well, I know what the adjacent side is. I know that it's 5. But what I don't know is the hypotenuse. I only was given the opposite side and the adjacent side. I wasn't given the hypotenuse. But it doesn't matter. Why? Because I know from my Pythagorean theorem that a squared plus b squared equals c squared. And that means that 5 squared plus the 3 squared is going to equal the c squared. This is 25, and this is 9, and 25 plus 9 is 34. So c squared equals 34, which means the c has to equal the square root of 34. So they don't have to give me all three sides of the right triangle. If they just give me two of them, I could figure out all three sides. I can figure out the third side. And after I figure out the third sides, and then I can do any one of these. The cosine, as remember, we said was the adjacent side, which was 5, over the hypotenuse, which we now know is the square root of 34. So my answer for the cosine of theta is 5 over square root of 34. I can find out any one of these, the sine, the cosine, or the tangent, as long as I know what my three sides are, and I'm very careful about looking at my angle and properly labeling which is the opposite, which is the adjacent, and which is the hypotenuse. Remember, this was now the opposite side because the theta was over here and not over here. Is there something wrong with this answer? Well, usually we do not leave a radical in the denominator. So what if we want it in proper format, we want to rationalize this, and we know the way we rationalize the denominator, if it's just a single term, is just multiply the top and the bottom by the radical. So we're going to multiply top and bottom by radical 34. So on top, we're going to get 5 radical 34. And on the bottom, radical 34 times radical 34 is just 34. I can't reduce anything because this is a 5 and this is a 34. Remember, you can only work with the numbers that are outside the radical. So in simplest radical form, my answer for the cosine of theta is 5 radical 34 over 34. That's what this is all about. Is there any question about this? Anybody want me to leave this on the board, or can I go on to another problem?
I'm sorry, I was having trouble with my computer. Could you repeat that? There's like a loud noise here, and it's making it really hard to hear, even though I have headphones on.
Okay, what would you like me to do? You want me to redo the whole problem, Corey?
No, just right after we did a squared plus b squared, like right after we solved all that.
Okay, so you got to the square root of 34?
Yes.
Okay, so now, did you see what I did? I put it over here because it's a hypotenuse. Now, remember the cosine is the adjacent over the hypotenuse, and I've labeled them. This is my adjacent side, this is my opposite side, this is my hypotenuse. So I want the adjacent, which is 5, over the hypotenuse, which is radical 34. Are you following that?
Yeah.
Okay, the only thing is usually we don't leave the radical in the denominator. So therefore, we rationalize the denominator by multiplying it by the square root of 34. Remember doing this? Because I know square root of 34 times square root of 34 will just give me 34. But whatever I do to the denominator, I have to do the same thing to the numerator. So my final answer becomes 5 radical 34 over 34. Just not to leave. There was nothing wrong with this answer except the format. They don't want a radical in the denominator. Are we okay now?
Yes. Thank you.
Okay. Can I erase it and give you another problem? Anybody still want this on the board? Okay, because I'd like to give one for you to try yourselves. You ready to do that? Okay. Here's a question.
Professor,
Yes.
letter is next to the cos equals A over H. Is that a D?
It's a D because I had a capital A over here for an angle, so I called this AD for adjacent. There are two A's here, and I didn't want you to confuse them.
Okay.
Okay, can I erase it now? Anybody still need it on the board?
No.
Okay. So I'm going to leave the SOHCAHTOA on the board because that we do need. That's the most important thing. Okay, here's a problem for you to do. Here, and I'm taking these off of old finals. Here's my theta. Here's my 3. Here's my 7. I want you to find sine theta. Okay, I'm giving you a couple minutes to do that. All right, let's see if we can work on this together. I didn't have any A, B's, and C's in here, but it doesn't matter. I still know that this is my right angle. I really should have put that little square in there. So this is my hypotenuse, and this is the angle that I'm looking at. Now, it says find sine theta, and I know sine is opposite over hypotenuse. So opposite over hypotenuse. So let's look at this. Here's my theta. Do I know what the opposite side is? Yes, this is my opposite side because it's right across from it. The opposite side is 3. Do we know what the hypotenuse is? Well, the hypotenuse is this one. And I have this side and I have this side, but I don't have this side. So again, I have to use the Pythagorean theorem. I have to do the a squared plus b squared equals c squared, because I have to figure out what the hypotenuse is. So the A, and it doesn't matter which you call A and which you call B. These are, the only thing you have to be very careful about is that you always call the C the hypotenuse, the one that's across from the right angle. So we're going to do 3 squared plus 7 squared equals c squared. So 3 squared is 9, and 7 squared is 49. That equals c squared. So when I add the 9 and the 49, I get 58. So that gives me c squared as 58, which means that the c has to be the square root of 58. Again, we only use positive numbers. So now, remember, I knew that the opposite was 3. I now know that the hypotenuse is the square root of 58. So the answer to this question is 3 over radical 58. But again, like we had before, we have a radical in the denominator. If the radical would be on top, I wouldn't have any problem with it. But here the radical is in the denominator, so I have to rationalize it by multiplying by radical 58 over radical 58. So this ends up being 3 radical 58 over plane 58, no radical. And 3 does not go into 58. There's no common factor. So there's my answer, 3 radical 58 over 58. Did anybody get that answer? Anybody?
Yes.
Zia, good. Okay. Let's do one more, and then we'll go on a little further. Okay, can I erase this? Any question? Can I erase it? Okay, Kashira, I'm leaving it on for a couple of minutes. Does anybody have any question about it while I'm? You're going to see all the problems are similar. You just have to be very careful about labeling your sides, opposite, adjacent, and hypotenuse, based on the angle that they're focusing on, whether they call it a theta or whether they call it an A or they call it a B, whatever it is. Always label your sides based on the angle that they're talking about. And then if you have to figure out a third side, then just do it. Okay, Kachira, can I erase this now? Okay. So let's try one more problem like this. Let's say I gave you a problem that looks like this. Let's put our theta over here. We never put the theta over here because this is always the right angle. The theta is never a right angle. It could be any other angle, but it can't be the right angle. Let's say this is 15, and this is 12. And I want you to find the tangent of theta. Okay, I'm going to give you a few minutes to try that. All right, let's do this together now. Here's my triangle. I know the tangent is TOA. TOA stands for opposite over adjacent. So we always figure out what we're looking for, and then we label our triangle opposite, adjacent, hypotenuse. Okay, here is my angle. My opposite side would be here. My hypotenuse would be here. And my adjacent side is the one that's connected to the angle, is here. So I told you, again, always look at the angle that they're focusing on and label your sides opposite, adjacent, hypotenuse. Now let's see what we need. The opposite side, we don't have it. The adjacent side, we do have. So if I'm going to find the tangent, I know it's going to be something over 12 because the adjacent side is 12. But I don't have the opposite side. So the first thing I have to do, and I see that Cheryl already was figuring it out to us, was figuring out the third side of the triangle. Remember, we always do the a squared plus b squared equals c squared. Now, sometimes I don't need that. Maybe they had asked me to find something that just needed adjacent hypotenuse and I added. But in this case, I need the opposite side. I don't have it. So I'm going to do a squared, which is 12 squared, plus b squared, which I don't know, equals c squared. Remember, the c is always the hypotenuse. So you could switch these two. But the hypotenuse always has to go over here on the other side. Okay. 12 squared is 144. B squared we don't know. And 15 squared is 225. So in this case, what I have to do is bring the 144 over to the other side to get what B squared is. Okay, I'm going to use my calculator. 225 minus 144 gives me 81. So b squared turns out to be 81, which means that my b turns out to be the square root of 81. That one's an easy one. That's a 9. It's a rational number. This side turned out to be equal to 9. So when I go to find the tangent, I do opposite, which is 9, over adjacent, which is 12. My answer becomes 9 over 12. But of course, I can reduce that because I can divide the top and bottom by 3. So in simplest form, it becomes 3 over 4. Usually, we give these answers as fractions. If you want, you could change it to a decimal, but by dividing the 3 by the 4 and get 0.75. But what we usually do is we leave it as a fraction. The tangent of theta for this particular triangle was 3/4. Any question about that? Okay, so I would like to go one step further. I told you there actually are 6 trigonometric ratios that we have to know. We have to know the sine, the cosine, and the tangent, but there are 3 others. I'm going to give you the 3 others, which are the secondary ones. Really, when we ask questions, we usually ask questions about these, the sine, the cosine, or tangent. The others, the secondary ones, are also sometimes called the reciprocal Good morning, Melissa. The reciprocal relations. So let's look at this particular example. Let's just leave these numbers over here. And talk about the names of the other three trigonometric functions that you have to know. One is something called the cosecant. Which is written CSC. We can't write COS because we're already using COS for cosine. So we have cosecant, CSC. Then there's something called the secant, which is written SEC. And finally, there's something called the cotangent, which is written COT. Remember, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. Each one of these is a reciprocal of one of the primary ones. The cosecant is the reciprocal of the sine. That's right, reciprocal over here. It's the reciprocal of the sine. The secant is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. Remember what a reciprocal is. It's just the thing flipped over. How am I going to remember which goes with which? I finally figured out SOHCAHTOA. I know what the sine is. I know what the cosine is. Now I have three more to deal with. Don't worry, these are the only three more that you have to deal with. So here's how I remember it. This is my own method. Obviously, the cotangent, the tangent, they seem to be a pair. In other words, since the tangent is opposite over adjacent, the cotangent is adjacent over opposite. The cotangent is the reciprocal of the tangent. It's just the whole thing turned upside down. Okay, so then we have these two things, the cosecant and the secant. So here's how I remember it. Notice, this starts with C, this starts with S. This starts with S, this starts with C. So the letters that we're dealing with are C and S. Cosine and sine, secant and cosecant. So here's what you have to remember. The cosecant pairs with the sine. The C pairs with the S. Whereas the secant, which starts with the S, has to pair with the C, which is the cosine. So the cosecant is the reciprocal of the sine. Remember, the sine is opposite over hypotenuse. So the cosecant is the hypotenuse over the opposite. It's simply the sine flipped over. And the secant is the reciprocal of the cosine, so it's the hypotenuse over the adjacent. So let's say in this particular problem that we had from before, where I had, this was my theta, my angle that I'm looking at, the opposite side was 9, the adjacent side was 12, and the hypotenuse was 15. This we have from previous information. Let's say I asked you to find the cosecant of theta. So here's what I do. I think cosecant pairs with sine. I figure out what the sine of theta is. I know the sine of theta is the opposite, which is 9, over the hypotenuse. So sine is opposite over hypotenuse. It's 9 over 15, which means the cosecant, before I do anything else, I'm just going to flip it over. The cosecant is its reciprocal. So the cosecant will be 15 over 9. All I have to do is remember the names because I already have all the information. Of course, I can reduce 15 over 9 to 5 over 3 if I want it in simplest form. But again, if I'm asked about the cosecant, I remember the cosecant, that pairs with the sine. Remember, tangent pairs with cotangent. Cosecant pairs with sine, secant pairs with cosine. C with S, except for the cotangent, which goes with tangent. That I think nobody has a problem with this one. It's these two that, do I remember the cosecant goes with the sine or with the cosine? So remember, if it starts with a co, its pair does not. The cosecant goes with the sine, but the secant goes with the cosine. Okay, let's do one more example. We basically have covered what you need to know about this. Tomorrow I'm going to show you one or two more problems. We're going to cover some other problems, but basically this is what you need to know about trigonometry. Obviously there's a lot more about trigonometry to know, but you are not required to know more than this. You have to know how to figure out the third side of a right triangle and how to go from find any one of the either three primary trigonometric functions, sine, cosine, or tangent, or one of the secondary ones, the cosecant, the secant, and the cotangent. Okay, can I erase this so I can do another problem? Anybody still need this on the board? Okay, so I'm going to put another problem on the board, and we're going to do it together. Remember, what I always do when I start out and I see a problem that talks about trigonometry, which I'll know by the words they use, I write out sine, cosine, so, ca, toa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And remember, cosecant, flip over the sine. Secant, flip over the cosine. Cotangent, flip over the tangent. That's the important things that you have to know. Okay, so let's see if I can get you a problem. Here's a picture that I'm giving you. Here's they're putting my theta over here. They're giving me this to be 1 and this to be the square root of 5. And they want me to find the secant of theta. Okay, I'm going to give you a couple of minutes to try it, and then we're going to do it together. Okay, let's see if we can work on this together. First of all, let's label what we have before we do any work. Here is my angle that they're giving me. So this is the side that's opposite. So let's call this my opposite. Obviously, here's my right angle. So this that they gave me is my hypotenuse. This, what they didn't give me, happens to be the adjacent. It's the one that's next to it. That's not the hypotenuse. That's what adjacent means, next to. Okay, now let's think about what is the secant. Well, I know the secant, it doesn't go with sine because it starts with an S and its partner has to start with a C. So it has to go with cosine. So I have to figure out what the cosine of theta is. And after I figure out what the cosine of theta is, then I'll flip it over and that'll give me what the secant is. The secant is the reciprocal of the cosine because this starts with an S. Its partner has to start with a C. Okay, now let's go to this. The cosine is the adjacent over the hypotenuse. So adjacent over hypotenuse. So let's see what we have. Do we have the adjacent side? No, we're missing it. So the first thing we have to do before I go any further is figure out what is the adjacent side. So I do my a squared, 1 squared, plus my b squared. This one's the one I don't know, equal my c squared. It's a square root of 5 squared because the hypotenuse is always the c. So 1 squared is 1, b squared is b squared. The square root of 5 squared is the square root of 5 times the square root of 5, which is simply 5. So I bring this 1 to the other side. That gives me b squared equals 5 minus 1, which is 4, which means that the b, the adjacent side, has to be equal to the square root of 4, which is 2. So the cosine of theta turns out to be the adjacent side, which is 2, over the hypotenuse, which is the radical 5, the square root of 5. The only problem with this is that we don't want a radical in the denominator. So we have to rationalize this by multiplying the top and the bottom by radical 5. So that my final answer becomes 2 radical 5 over 5. So that's how I do this problem. There's only one step further than finding the cosine. One step further when you're asked to find one of these secondary functions is that after you get your answer, I'm sorry. Scratch what I just said. Scratch what I just said. Sorry, I was finding the cosine. The cosine is the adjacent over the hypotenuse, which is 2 over the radical 5. That far I was correct. But I didn't ask you to find the cosine. I asked you to find the secant. And the secant is simply the reciprocal of this. So once I get the cosine, all I have to do is flip it over, and I get the square root of 5 over 2. I don't even have to rationalize this one because the denominator doesn't have a radical in it. So before I do any rationalization or anything, don't do what I do. Remember, you're not asked for the cosine. We figure out the cosine first, but since they asked for the secant, we have to flip it over. The cosecant, the secant is the reciprocal of the cosine. So we put the square root of 5 on top and the 2 on the bottom. Okay, we're going to review this next on Friday again. But right now, what I'd like to do is start a review for the final exam by doing a review of the type of questions that come from chapter 1. Chapter 1 was a chapter about solving linear equations, whether they have whole numbers or decimals, solving inequalities, and solving absolute value equations. So let's see if we can do one of each of those type of problems. Remember, you can, any topic that you feel you want to go over in more depth, please let me know either by an email or by letting me know in person. Just tell me, I really need you to go over topic absolute value equations better. So then I will spend more time on it. But right now, I'm going to leave this trigonometry. We're going to review it tomorrow. And we're going to go on with our review of chapter 1. Again, you want to test yourself on how well you know the chapter 1. Go to the review study guide, the study guide that I sent you. It's in the information page. It has important information and examples about each chapter. We're covering chapter 1. So the first type of question that we learned on chapter 1 was to solve an equation. So let's remember if we know how to solve this. Suppose I gave you 8y plus 4 times 6 plus y equaling 3 times y minus 4 plus 10y. Okay, I'm going to give you a couple minutes to solve this equation. This is where we started off our course as a review of things that we had learned in previous courses. I'm going to give you a few minutes. This is a good way for you to check if you remember all the topics, because all at the final exam covers the topics. As far as I know, it's going to be 30 multiple choice questions from the beginning of the term, not from the midterm, but from the beginning of the term. Okay, everybody want more time? So let's get started. Remember, when we're solving a linear equation, the first thing we want to do is remove our parentheses if we see any, and of course there are parentheses, so we use the distributive property. We leave this 8y, and here we do 4 times 6 is 24, and 4 times y is 4y. Remember, we're distributing the 4 because it's in front of the parentheses. On the other side, we're going to remove the parentheses by distributing the 3. 3 times y is 3y. 3 times -4 is -12, and plus 10y. So we remove our parentheses, and then the next thing we do is on each side, we try to collect the like terms. Well, here there's an 8y and a 4y, so those are like terms. That becomes 12y plus 24, we leave. And over here we have 3y and 10y. Those are like terms. That gives me 13y minus 12. So I collect my like terms. Then I bring all the y's, and I always like to bring the y's to the left side. I'm going to bring the y's to the left side, so I'm going to do minus 13y from both sides. And 12y minus 13y is minus y plus 24 equals -12. So now I have to bring the 24 to the other side. And I get -y equals -36. And of course, I don't want -y, I want y, so I'm going to divide by -1 on both sides. So I get my final answer is y equals 36. The only thing that you have to be careful about is not making mistakes, silly arithmetic mistakes, because this is a classic standard type of question that I'm sure everybody in this class knows how to do. Any question about this one? Okay, so let's go to another problem. The next type of problem that we're going to talk about is an inequality. Okay, so let me give you a picture, an example of an inequality. I'm erasing this. And let's say we have this inequality. Negative 13x plus 7 is greater than or equal to negative 12x plus 9. And I'd like you to solve it, give the answer in 3 different formats: as an inequality, as an interval notation, and as a graph on a line graph. Okay, I'm giving you a couple minutes for this. Okay, I know I'm probably rushing you, but I would like to finish this up. When we have an inequality, we solve it just like we solved a regular equation, except we always make sure to have the x's on the left side. So I'm going to bring this negative 12x, I'm going to add 12x to both sides. So negative 13x plus 12x gives me negative x plus 7 greater than or equal to 9. Now I bring the number, the 7, to the other side. So I'm going to subtract 7 from both sides. so that I end up with negative x greater than or equal to 2. Now, I can't leave it a negative x. I have to have a plain x. So I have to divide both sides of this by -1. Don't forget, when you're dividing by a negative number, the direction of your inequality switches. So this becomes positive x. This becomes less than or equal to, and 2 divided by -1 is -2. This is your answer in inequality format. If you're doing this on Delta Math, you want to go back and do problems on Delta Math, or you want to review some of the tests or whatever, you have to type in the X, you have to pick they give you a few boxes with different symbols. You pick the less than or equal to symbol and click on it, and then you type in -2. What does this look like on a number line? Well, here's your 0, -1, -2, 1, 2. What you do is you have to go to the -2, and it's a filled in circle at -2 because this is less than or equal to, and the arrow is pointing to the left. This is what it would look like on the number line. Now, for those of you who had trouble using the number line on Delta Math, what you have to do is you have to click on -2 and hold your mouse down and drag it to the left. Drag it as far as you can before you let go. Make sure you're going all the way off. Then look at this. I think the default is that it's always a filled in circle. If you don't want it to be a filled in circle, if you want it to be just a plain less than, let's say this was not less than or equal to, it was just a less than, then you have to click on that filled in circle and it becomes an open circle. But in this case, we need it to be a filled in circle and an arrow pointing to the left. In terms of interval notation, all the way to the left is -infinity. It's going from -infinity until -2. Don't forget, when you have an infinity sign, whether it's negative or positive, the symbol that goes with it is always a regular parentheses. On the other side, the -2, if it's filled in, if it's included, then you have to make it a brackets. If this would have been an open circle, this would have just been a plain less than, not a less than or equal to. That would have been a parentheses as well. So in interval notation, this is parentheses, -infinity, comma, -2 brackets. And they probably give you on Delta Math these type of choices, but if not, you could just type it in from your keyboard because you can pick parentheses and you can pick brackets. Any question about that?
Anita, thank you, Professor. So the only issue I had was it wouldn't allow me to place I guess the dots where I wanted it to. It was giving me
When you take the mouse, get your mouse, don't click on your mouse until you get to the number that you want. Let's say you want -2. Then click on it and hold it down as you drag it to the direction you want it to go.
okay. I guess I have to get a mouse because right now I'm just using the pad on my
Okay.
and it's so hard.
Though my computer came without a mouse, I always like to use a mouse. I get a mouse. I find it's much easier to control. I'm trying to think if you're using your finger, again, just put your it's harder because it's easier to control with a mouse, but you have to put your finger and hold it down and then drag it.
Okay, thank you. I'll try that, Professor.
Okay, so now let's do at least one more problem. I see we're getting sort of, and that is a absolute value equation. Let's say I gave you something like this. The absolute value of 3x minus 7 equals 5. What you want to do when you have an absolute value equation is, number one, see if there's anything outside the absolute value. Let's say there was a +2 over here. You first have to bring it to the other side. You have to start out with your absolute value being all by itself. It has to be isolated. Then, after it's isolated, you look at this number that's on the other side. If this number happens to be a negative number, it's telling you that this is an impossible situation. You cannot have the absolute value of something equaling a negative number. We had that also when we had square root radical equations. When we have radical equations, you can't have a radical equaling a negative number. You can't have an absolute value equaling a negative number. So if this would have been a -5, I would have stopped right there and wrote no solution. Or if you remember, it's that O with the line slash through it. But in this case, we can go further. We have to write two equations. The first equation is 3x minus 7 equals 5. The second equation is 3x minus 7 equals -5. Because the absolute value of something, then what's inside could have originally been positive or negative, because the whole point with absolute value is that you make it a positive. So now we don't have any absolute value signs. We can just solve these equations. Here I add 7 to both sides, which gives me 3x equals 12. So x equals 4 is one answer. Then I add 7 to both sides over here, and I get 3x equals 2. And when I divide by 3, I get 2/3. So my answers are 4 and 2/3. With absolute value equations, you end up with two answers, one from the positive and one from the negative. Any questions? Don't forget, the most common mistake people make is they just drop those absolute values and just give one answer. You need to give both answers. And we have 5 minutes, so let's do just one more problem. This is a problem about perimeters. They very often ask questions about perimeters of rectangles. Can I erase this? Okay. Suppose we're told the length of a billboard is 9 more than the width. And the perimeter is 166. And they wanted me to find what the width is. Sometimes they ask you to find the width, sometimes they ask you to find the length, and sometimes they ask you to find the dimensions. Now you have to read carefully what they're asking for. If they ask for the dimension, it means they want you to give both the length and the width. Now, I like to do this by drawing a picture. We're told that the whole perimeter is 166. That's everything all around. Let's label our sides in terms of x. Since the length is 9 more than the width, here's my width. Let's call this one x and this one x. We're calling our with the x. Then the length, 9 more, is x plus 9. Remember, 9 less would be x minus 9. 9 more is x plus 9. We add 9 to the x for more. We subtract 9 from the x when it says less. So this is also x plus 9. And your perimeter is all 4 sides added together. So if I add them all together, and I'm going to do it just like this, x plus x plus x plus x gives me 4x. And 9 and 9 is 18. That's going to equal the 166. And now this is an easy equation to solve. I subtract 18 from both sides. That gives me 4x, and I'm going to use my calculator. I can find it. 166 minus 18 is 148. And then I divide by 4 to find out what x is. So I'm dividing this by 4. It's so much easier to do it when you have a calculator. I get x equals to 37. And x was what I was looking for because it asked for my width. My width is 37. If it had asked for my length, I would have had to do 37 plus 9, which would have been 46, but they didn't ask for that. They just asked for the width. Be careful that you give them the answer you give the answer to what they're asking for. Okay, I think we're going to stop right here. That was a review of the type of questions that come from chapter 1. I'm going to stop the recording now.